Okay, this is your assignment number 7 BT. In this they said a balanced 3-phase star connected load means it's a star connection, and as you know, in the case of star connection, line current would be equals to phase current and line voltage would be equals to √3 times of phase voltage, right? Is connected with a balanced 3-phase 3-wire RYB system, and if the line voltage VL is how much? 442 volt, right? The load impedance per phase, so load impedance means that PH is how much? 39 plus J80. Then the magnitude of the load voltage, VPH we need to calculate. That would be VL by √3, 442 divided by √3. So this is the magnitude of the load voltage. Okay, because across the load basically they are asking the voltage. If I'll draw the diagram of the star connection, see, star connection diagram is like this. Yes or no? This is R, this is Y, this is B. So basically this is the load, correct? And they are asking the voltage across load, correct? Yes or no? So voltage across load means they are asking the VPH value, right? So because this is at PH, so VPH is how much? That would be VL by √3. Okay, now read the question number 2. Now see, in this case the line voltage VL is equals to 444 volt and ZPH is equals to 67 plus J54. So you can convert it into the polar form. They are asking the magnitude of the load current, means they are asking the IPH, that is VPH divided by ZPH. So again VPH is how much? 484 divided by √3, and ZPH they want only the magnitude. So whatever the magnitude you will get it here, you can put it here, or another formula is R square plus XL का square, right? So 67 का square plus 54 का square, ये वाली वैल्यू एंड ये वाली वैल्यू सेम आएगी. या तो ऐसे कर लो, you can convert it into the polar form, or you can do it by this method. Then after solving you will get the IPH value. Okay, so its answer is 3.24 ampere, right? We'll have 3 triangles. One is impedance triangle, another one is the voltage triangle, and another one is the power triangle. Okay, so to calculate phi we can use any of the triangle, whatever the values are given, like depends on what they have given. In this, according to this, they have given the ZPH is how much? R plus JXL. R is 55 and XL is 66, right? So that means these values are given. This is R, this is Z, and this is XL or XC. So if I'll calculate cos phi is how much? R by Z, right? Tan phi is how much? XL by R, correct? So from this, if I'll calculate tan phi is how much? XL by R. XL is how much? 66 by 55. That would be the tan phi. So from here we can get the phi value. That would be tan inverse of 66 divided by 55. Okay. So whatever the phi value, that is your angle. Okay. Now see what is in the voltage triangle. We'll have VR, VL or VC, or the total voltage V. In the power triangle we'll have active power, reactive power and apparent power. So whatever they have given, you can calculate phi from any of the triangle or from any of the values. Clear? Calculate it. Yes. So in this case also, phi is how much? Tan inverse of 94 divided by 69. Okay. Again they are asking the angle only. So tan inverse 84 divided by 17. Okay. In this they are asking you the power factor. Power factor is cos phi. So cos phi we need to calculate. So for that we need to calculate phi. Phi is how much? Tan inverse XL by R, that is 90 divided by 27. Correct? So from here you can get phi, you can multiply it, you can get cos phi. Or you can get directly cos phi by the formula R by Z. R you know 27, Z is how much? 27 ka square plus 90 ka square. You can do it by both the method, answer would be same. Okay. See, active power formula is 3 VPH IPH cos phi, right? So cos phi is how much? R by Z. R is 25, Z is 25 ka square plus 76 ka square, right? And we need to get IPH also. IPH is how much? That is VPH divided by ZPH, correct? So we already know the value for VPH. It's a star connection, so VL by root 3, so 500 by root 3. ZPH is how much? Root of 25 ka square plus 76 ka square. So from here we can get IPH, right? Cos phi from here. VPH is 500 by root 3. You can substitute the value, then you will get the final active power. Got it? So see, it's a case of balance delta. In delta, VL is equals to VPH and IL is equals to root 3 IPH. So VL is equals to VPH is equals to 432 volt and ZPH is how much? 56.5 angle minus 65 degree. We need to calculate IPH, magnitude of the load current, right? So that is VPH divided by ZPH. VPH is 432, ZPH is 56.5, angle is minus 65 degree. You can solve it and then you will get the answer, right? Now in the question number 9 they ask you if the voltage, line voltage is this one, means that is equals to phase voltage only, 476 and impedance is 72 angle minus 75 degree. Then they are asking the magnitude of line current. Here they are asking the magnitude of the load current. Load means it's in phase. Okay. So load, another name is phase. You can write it down also. Otherwise students got confused. Load बोला है तो phase ही है. But here they have mentioned line current. So from here we can get IPH by the formula VPH by ZPH 476 divided by 72 angle minus 75 degree. They are asking line current. So how can we get line current? As you know the formula, IL is equals to root 3 IPH. So whatever the value you are getting for IPH, you can substitute it over here, right? See, in this case what we need to calculate power. What is the formula for the power? That is P is equals to 3 VPH IPH cos phi, right? So cos phi, phi is given directly, the angle of impedance is the phi only, so cos of 25, IPH is VPH by ZPH, so 450 divided by 67, because for the calculation of power we don't want angle, we'll take only the magnitude. So VPH is this one, ZPH is this one, 3 as it is, VPH is 450. So solve it, then you will get the value for the power. Now on the next question, problem number 3, this is unbalanced delta. In this they ask you the magnitude of the current flowing through impedance ZAB. So basically we need to calculate IAB, right? That would be equals to VAB divided by ZAB. So remember I told you, like, if they have given you the sequence of ABC, so VAB, then VBC, then VCA, right? So the voltage is how much? 440 angle 0 degree, then 440 angle minus 120 degree, then 440 angle plus 120 degree, or we can say 440 angle minus 240 degree. So VAB is how much? That is 440 angle 0 degree. ZAB is given, that is 44 ohm. We can get the current easily, right? So it would be 10 ampere angle 0 degree. This is the value for IAB. Got it? So in this case we need to calculate IBC, that would be VBC over ZBC. VBC is how much? 440. Sorry, how much angle is given? 440, no? Voltage is 440. The standard they have given. So 440 angle minus 120 degree, and ZBC is how much? Minus J68. So if you solve it, you need to convert it into the polar form. Then that would be 68 angle minus 90 degree, 440 angle minus 120 degree. You can solve it, then you will get the answer for IPC. Okay. ICA is VCA divided by ZCA. So that would be 440 angle plus 120 divided by ZCA is J42. So it would be 440 angle plus 120 degree, 42 angle 90 degree. I convert it to the polar form. You will get the answer. Okay, so now in this case they ask you to calculate IA. IA is how much? IAB minus ICA. Remember I told you the sequence की RYB की sequence है, तो IR is equals to IRY minus IBR. So these formulas are given in your handbook also, but in form of RYB. तुम्हें ABC की form में निकालना है. So IAB, how can you get IAB? For that you need to calculate. So that would be 440 angle 0 degree divided by ZAB, that is 28, minus IAB BCCA, so 440 angle plus 120 degree, and ZCA is how much? J52, or we can write down 52 angle 90 degree. So basically you need to solve it and then you will get the IA, right? Similarly they ask you this one, the magnitude of the current flowing through line B. So basically they are asking you the IB. Now IB formula is what? IBC minus IAB. ABC की sequence है, तो B से C and then A to B, right? IBC is how much? Again 440 angle minus 120 degree divided by ZBC, that is minus J34. IAB is how much? 440 angle 0 degree divided by ZAB, that is 48. Got it? Now similarly, tell me for IC, what would be the formula for IC? See, in this case we need to calculate total power, right? So total power is how much? PAB plus PBC plus PCA. Yes or no? PBC is purely reactive because they said ki 0 minus J46, right? So see, if 0 minus J46 means there is no resistive load, and there is no resistive load, then active power consumed by them is 0. Like see, if we'll have three load, one is resistor, one is inductor, and one is capacitor. Okay, in this it actually consumes active power, but reactive power is 0 for the resistive load. For inductive and capacitive load, it actually consumes reactive power, but active power consumed by them is 0. Okay, and if angle is 0 degree, then we consider that it's a resistive load. If angle is 90 degree, then we consider it as a inductive or capacitive load, right? So according to their values, so ZBC is 0 minus J46, means there is no resistive load, right? Only capacitive load is there. So if there is only capacitive load, then active power consumed by them is 0. Sorry, here it is 0. So can we directly write it down 0? Similarly, ZCA means 0 plus J26, means only inductive load is there. In case of minus, capacitive load hota hai, and in case of inductive, in case of positive, inductive load is there. So in this also resistive nahi hai, so active power is 0. But यहाँ पे there is a resistive load, so there would be some power by the formula I square AB multiplied by RAB, right? RAB is given 44. Current we have calculated in the previous cases, so you can find out the value for current, then that would be the total power. ठीक है? Or you can get the current. Current का formula is I is equals to VPH divided by ZPH, right? VPH is how much? 440, because they have given you the standard voltage. कितनी दी हुई है? 440 है ना? हाँ. So it's a resistive load, so we can consider 440 angle 0, and ZAB is how much? Or you can write it down as VAB divided by ZAB. VAB is 440 angle 0, ZAB is 44, so current is how much? 10 ampere. So it would be 10 ka square. So the final total power is 4400 watt. This is your final answer. Okay. See, in this case they said 3-phase 4-wire. Why they said 4-wire? Because in star connection 1 wire is the extra wire, that is neutral. Okay, ABC supplies given, star unbalanced ka case hai. Now they said if the line voltage is 392 volt, ZA, ZB and ZC they have given the values. The magnitude of the current flowing through ZB, right? So basically we need to calculate IB, right? That would be VB divided by ZB. Yes or no? ZB is given, that is minus J40, correct? We need to calculate ZB. We need to calculate VB, right? So they have given you the line voltage, correct? So VL is equals to root 3 VPH. So 392 divided by root 3, correct? So you can get the magnitude, whatever the magnitude you are getting for, and it's for B part. So angle is how much? Minus 120 degree. Okay, calculate it, how much it's 392 by root 3 is how much? Now see, after solving we'll get VB as this one and IB is this one. Now in the next part they are asking the current through impedance ZA, right? So again we have to use this formula, that IA is equals to VA by ZA, right? So A hai the voltage is how much? 374 by root 3, correct? Because we need to take the phase voltage, they have given you the line voltage. Angle is 0 degree because it's A divided by ZA, that is 54. Correct? Similarly, now see, they are asking the magnitude of the current flowing through the neutral wire. So for that, we'll have the formula for the neutral wire, that IN would be equals to IA plus IB plus IC, right? So we have already calculated IA, IB, IC. Tell me how we can do it further. Angle. So IA is VA by ZA, right? So VA is 352 by root 3 angle 0 degree divided by ZA is 32, right? Then IB is VB by ZB. So again 352 root 3 angle is minus 120 degree divided by ZB is minus J50. Correct? Then again I'm writing over here. IC is VC by ZC. So VC is 352 by root 3. Angle is plus 120 degree divided by ZC, that is 32 ohm, right? So if you'll solve it, and then you will get the neutral current. Okay. If they want you to, basically they are asking magnitude now, so whatever the neutral current, you have to convert it into the polar form, and from that polar form they are asking the magnitude of the neutral current. Don't solve it in the rectangular form. अगर rectangular form में आ रहा है तो उसको polar form में convert कर लेना. ठीक है? Now this is your assignment number 7, right? So if you have any doubt in this assignment, then let me know.